You all know Randy Bush. He's chaired the chaired the steering committee of NANOG and has done a great deal of research over the last 15, 20 years on internet topology and so forth. He's going to be giving, yep, you can click on it. Go for it, Randy. Sorry.
No, you click on it.
Which
you
one?
Make it work. I don't know.
What we want for Christmas?
No.
No? No, this is Revenge of the Stupid Cool, right?
Yes.
Uh-oh. Okay.
Okay, Todd,
Sorry,
you said
Todd.
you'd had everything set up here. Whip
we
it
need
out,
Todd.
son. How do you think?
Money fold up on the desktop at the top. There you go.
There we go.
Okay, this is not the subject of the talk. This is just the first couple slides because I really care what you care about this, which is there was a meeting week before last, an ITF interim meeting in Montreal to talk about V4 and V6 coexistence and mechanisms. The IBF-TF has been talking about this for 10 years, ever since they designed a new protocol that was totally incompatible on the wire. Duh. They divided the solution space into two translators, i.e. NAT-PT replacements, and you're using NAT-PT here, and tunnels for the large consumer ISP problem. The translators, they've divided into three areas. SIIT, which is V6 host to V4 host. In other words, the V6 originates out, and this is to solve the problem of my customers who are enterprise customers who 3 years from now will not be able to get IPv4 space. Then DNS fabrication to give the V6 only host, the V6 address for the V4 host that's out there. It's known as TOTD. That's also part of NAT-PT that you're running here. And then there's a discussion of other mechanisms like IVI, et cetera, to deal with large V6 and large V4 meeting. And that's still mushy. The other was tunneling, like dual stack light, carrier grade NATs, port borrowing, et cetera. The thing I want to, okay. Please, if you're at all interested in this and you are deploying V6, please catch me elsewhere, because I think if this is not the right set and doesn't cover what you need, we need to go beat up some people. Okay? I mean, this is hopefully the last go-round on this fantasy. This is the real talk. An addressing hack to deal with carrier-grade NAT, which you've heard about here before. A gang of us are working on this alternative to it. The problem statement is, as you've heard here before, large broadband providers have an edge that is so big that they can't get enough V4 space to assign a 32 to each one of them to run NATs. Okay? And this is a real problem. So how do those 5 jillion users get connectivity from their homes? It's a consumer space problem. It's not an enterprise space problem. Why I'm concerned about this is because what they're suggesting is something called carrier grade NAT, which is NAT in the this isn't really working. I probably have to turn it on or something radical like that. No, it says on. Boopity 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 boop. Working? Sorry. Thanks. Carrier grade NAT, which is essentially a NAT in or near the core of the carrier's network. The user is in their little home network. The front of their consumer premises equipment has a V6 address, and that's NATed out there. The carrier grade NAT breaks the network. It is a NAT. And let's face it, when you design a new protocol like V6 that is on the wire, leaving it incompatible with IPv4, you are going to NAT. Get over it. But my is the way this NAT happens, and that it's a NAT in the center of the network, so that these are captive customers. And I won't be able, I don't run a broadband network, but I run an enterprise network where there's enterprise customers, but it's the same thing's true for everybody, is because the NAT's in the core of the network, I can't arbitrarily deploy new protocols, and Todd and I can't agree to try Skype version 3, where he just fixes his home network and I fix my network and we try it. It's got the problem of walled gardens. I wanted a nice pretty picture of a walled garden, you know, with flowers and everything. I went to Google Images, Googled walled garden, and this is what I got. Literally, this is what I got. It's not really correct. And Steve Bellovin gave us a more correct picture, which is this one. The people inside the walled garden don't know how bad they have it, and they don't have real internet. They've got a hack thing that gives them bad performance for IPv4. The people B who own the wall, they're the ones who make the money, and all the rest of us can go FSCK, right? This is a real problem to me because my customers are in C having trouble doing reasonable things with the people inside A. Okay? So, this is not inevitable. What can we do? Put the NAT, there's going to be a NAT, live with it. Move it to the CPE where the customer determines their own fate. But how the heck can I do that? I don't have enough v4 addresses to give each one of those CPEs v4. This is going to be difficult. But Allah says we can redeploy CPEs out there. And the scheme I'm proposing even does incremental deployment, et cetera. So you can roll them out as part of a new contract. If you can't roll the CPEs immediately, then run a dual stack core. You already have them addressed with v4 addresses. Done. No need to break the internet. Here's the hack in one slide. Do the work with the CPE so the customer can control their fate. They can replace the CPE. They can put in an ALG, whatever they need. Steal bits from the port number to extend the IPv4 address. Encapsulate this extended address in a v6 packet that has this extended address hacked into a special v6 prefix, and normal routing works, the border routers encapsulate, decapsulate, etc. But this is like Scheme X. Everything's like Scheme X. Nothing new is invented. Just for your example, in 1981, when the ARPANET was running out of address space because they were getting more than 64 institutions, was it, Vint, that it ran out of? But anyway, needed to add more institutions. Long leader address extension. Nobody wanted to rewrite the kernels because it's 81. TCP is coming. I can smell it, just like v6 is coming, except TCP did come. And so Greg Noel hack, stole unused short leader. You know, this is all, we have all been here before. Okay, how it works. Modify the CPE. Configure the CPE to use a restricted range of ports. Take the rest of the port numbers and use that to issue the same 32 to multiple CPEs. And you can make the configuration of this as complex as you want. You can modify DHCP and let people bid dynamically for how many port numbers, et cetera, et cetera. If you want to make it complex, go for it. I don't think you have to. And there are now studies out showing that how many ports are actually used. There's enough hacked address space around. Okay? How it works is the v4 data, you take a well-known v6 prefix, okay, and you make the source of the v6 packet leaving the CPE, the well-known prefix, plus the 32-bit address, plus the port numbers you've stolen. The destination is the hacked prefix, plus the real v4 destination. So it does normal v6 routing and gets to the appropriate border router in your v6 only network. There, the v6 is decapsulated. It's got a v4 destination inside. Whoosh, off it goes. Okay, normal routing's used. CPEs based on real destination, no pre-configured tunnels with endpoint. There is no state anywhere in the network except normal NAT state at the CPE that you've already got at all those CPEs. So the hacking is only at the CPE in the border. No new equipment. I'm sorry, my friends at Cisco. I've got Cisco stock. What can I say? It's a bummer. And the border routers have no state or scaling issues. Encapsulation back coming the other way is about the same. No sense going into details. So CPEs change, border routers change. If you want to get into the kink of variable or dynamic length port things, you can make your life complex. You can use extended DHCP. You can do all that stuff, et cetera, et cetera. And if you want to V6, it's pure V6 transparent because the network has a V6 core. So the V6 to V6 works just fine. Transparent, real internet, et cetera. You can do it in a V4 only core, but you don't want to. And that's about the end of it. Thanks, Dave Ward, Cisco, for beating me up endlessly with, but how does this part work? How does that part work, et cetera?
So because we have a little bit of extra time, I'm going to allow 2 questions, even though these are lightning talks, in between each. So I'll get that, unless there are 2 questions.
Go for it,
already.
Dino. Come on, Dino.
Good. Okay.
Oh, Vint beats you to it. He's wily and older.
You know, I'm going to allow 3 questions and then. Go ahead.
Okay, Randy, thank you for your usual enthusiasm. Have you actually implemented and tested so that we have some idea that
We do have
it's more than just
we have a hack implementation, yes.
Okay.
So my question is about the /64. It's a PI prefix, right? So do you plan to have some aggregatability address?
You're talking
Talking about the hack v6 well-known prefix?
Yes.
It makes no difference what it is. If you'll notice, the particular one I chose should tell you that, Jesus, why is it?
The 444.
Yeah, but considering it started with a 4, you should know that it's magic and really makes no difference what it is.
Well, what I'm worried about is that we don't want to do flat routing on sites for these sites that can't get V4 addresses in the V6 core. So I'm
This
wondering-
is a broadband provider
Yes,
with a jillion pieces at the CPE edge.
but it would be nice, they would like to aggregate those as well to regions of the network, right?
Right, works perfectly,
Okay. So
right? Because they do slam out, their V4 is aggregated already. They already are used to, I mean, why don't we let Alain talk, but they're used to
you're
aggregate.
saying the next set of bits that's after the /64
It-
the IPv4 prefix bits, which has aggregatability in it. Okay. So
Bingo!
it's going to be /6. How are you going to do it, Elaine?
Not like this.
Okay, I think that was a lightning enough question. Alain?
Okay.
I would like to quote somebody that I have a great deal of respect, who said, the issue is not the location of the NAT, but who has control of it. And that person was Randy Bush. So we have taken this into account because we don't want to be in the business of running your ALGs. This is just way too complex. And if we can deploy things with no ALGs, even better. So we are integrating this notion of putting the control of the NAT back to the user. And this is now integrated into the dual stack Lite. And I've submitted a lightning talk, and I hope that the program committee will give me some time, sometime this week, to go in details and answer how we can do this without this 4666 hacking.
Excuse me for making believe that was a question, Alain. What Alain is saying, as I said at the meeting 2 weeks ago, what's important is the customer have control of the translation so that they cannot be forced into a walled garden. What Alain is saying is, look, because these carrier-grade NATs don't really scale well, they're going to be near the edge anyway. So what about if I give the customer control of their part of that NAT? And I think that would be wonderful, except I keep reading about this particular broadband provider and the FCC and Congress, et cetera, and how they're already in deep doo-doo for screwing the users in the walled garden. So the idea that I'm going to go and be able to get some control over a NAT, which really they and their lawyers control, haha.
I remember PSI gave customers a bit of control over their internal routing also, and a lot of other ISPs chose not to follow suit. Okay, thank you very much, Randy.